All right, class. So welcome to chapter 4, which really talk about the atom. This week, we're just getting over chapter 4, section 1, where we will define the atom. I'm feeling a little under the weather, so I'm just keeping my video turned off. I apologize for that. But early models of the atom. So an atom is the smallest particle of an element, one of those elements in a periodic table, that retains its identity in a chemical reaction. Propose ideas about the structure of the atom. So we'll kind of go through some of these early models of the atom. So Democritus, 460 to 370 BC, which is amazing, quite a while ago, he was the first person to propose the idea that matter was indivisible and indestructible, and that states that matter was made up of were of individual particles called atomos. And the atom is the smallest piece that any substance can be broken down into. So they were already able to figure that out. He proposed a discontinuous theory of matter, but was criticized because he was not backed by evidence. So that's Democritus, kind of the very, very early view of the atom. Aristotle, 484 to 322 BC, he disagreed with Democritus because he did not believe empty space could exist. He also believed that matter was made up of earth, fire, air, and water. And Aristotle's views actually went unchallenged for about 2,000 years until science developed methods to actually test the validity of his ideas. So then we get kind of a little bit of the overview of these Greek ideas. We have Democritus and Aristotle, where Democritus, much earlier, said that matter is composed of atoms which move through empty space. Atoms are solid, homogeneous, indestructible, and indivisible. There's different kinds of atoms that have different sizes and shapes, and the size, shape, and movement of atoms will determine the properties of matter. And then Aristotle said that empty space cannot exist, and that matter is made up of earth, fire, air, and water. So both a little bit off, but is pretty amazing that without any sort of scientific technology, they were able to come up with this idea of the atom. Then we get to Dalton. So many years have passed. We're in 1766 to 1844 was Dalton. He was an English teacher who was fascinated with meteorology. He revised and reviewed Democritus's ideas, and he only performed many experiments. He made both quantitative and qualitative observations, and he developed Dalton's atomic theory in 1803. So this would be the theory of the atom by Dalton. So Dalton's atomic theory says that all matter is composed of atoms. Atoms are indivisible and indestructible. Atoms of a given element are identical in size, mass, and chemical properties. Atoms of a specific element are different from those of another element, and different atoms will combine in simple whole number ratios to form compounds. And in a chemical reaction, atoms will be separated, combined, or rearranged. So these are kind of the 6 main key steps of Dalton's atomic theory. It has been revised over time with the advancement of technology. Some modifications are that atoms are actually divisible because we can divide them into subatomic particles, protons, neutrons, and electrons. Atoms are destructible. All atoms of the same element are not actually identical if they have lost or gained an extra electron. So we have modified Dalton's atomic theory. A little bit of a summary of him. Again, he said that matter is composed of extremely small particles called atoms. Atoms are indivisible and indestructible, which again we've revised since then. Atoms of a given element are identical from those of another element. Different atoms will combine in simple whole number ratios to form compounds, and in a chemical reaction, atoms will be separated, combined, or arranged. Sizing up the atom. So the Dalton concept of the atom, let's talk about liquid mercury, for example. Every drop, no matter its size, has the same properties as the chemical properties of mercury. A copper coin, for example, if you grind a copper coin into a fine dust, each speck of copper dust would have the same properties of copper. Atoms are very small, but despite their small size, individual atoms can actually be observed with instruments like the scanning electron microscope, which is really cool to see. Scanning electron microscopes send a beam of electrons focused in on a sample. The electron microscopes are capable of much higher magnification than light microscopes, and individual atoms can be moved around and arranged in patterns. The ability to move individual atoms holds the future promise for the creation of potential atomic-sized electron devices and other circuits and computer chips. So here we have just a look at the scanning electron microscope. The electron beam, so the electron gun sends out electrons through an anode, through a magnetic lens, through scanning coils. It's backscattered into the electron detector, and then eventually will be placed on the specimen. The secondary electron detector then kind of is able to pick up and then send that of the sample that it's looking through to a UV scanner. So that's how a scanning electron microscope works. And that is the end of this section. Pretty simple, just giving you a little history of the atom. The lab handout that I put in there for you this week is probably more going to talk about things we talk about in sections 4.2 and 4.3, but you can still kind of do it and start working through this information. So thank you for listening, guys. God bless your studies, and we'll see you for the next section.